Hello everyone, this is Guy Glantser. I'm really excited to be here. This presentation is about parameterization in SQL Server, about how to handle parameters in SQL Server. And I really love this topic. The reason I love this topic is that I've been using and working with SQL Server for I think 17 years. I've seen so many use cases, customer case studies, where there were performance issues. And I think in most cases, the reason for the performance issue was the mishandling of parameters inside the code. And sometimes the solution is easy, sometimes it's complicated, but it always has something to do with parameters. And I teach this topic in conferences, in courses, and people always say, wow, I didn't know that, I didn't know that, I have to go back to my work and do something else, something better. And it's always great feedback, so I guess as long as I'm going to get that feedback, I'm going to continue doing it. A few words about myself. Again, my name is Guy. I work for Madeira SQL Server Services. We do professional services for SQL Server, whether it's infrastructure, administration, development, BI, Azure, big data, a lot of performance tuning. We are an Israeli company, but we operate globally. That's what we do. Again, I've been using SQL Server for a long time, and I love this topic of performance tuning and specifically parameterization. I'm going to talk today about plain caching, how the plain cache is used inside SQL Server. I'm going to talk about how we can write a query, how we can execute a query. There are 7 ways that I'm going to show you, and the differences between them. I'm going to talk about parameter sniffing, which is a very important topic, the pros and cons, and when is it good, when is it bad. What happens, what do we do when we have a non-uniform data distribution in our tables. A few things about when you change parameter values inside your stored procedures, which is a very important subject. And I'm going to summarize with simple versus forced parameterization. I'm going to talk about it later, so I'm not going to explain it now. Of course, the summary, let's start. I want to start with a story. And again, this story is something that I encounter maybe a daily or weekly basis with our customers. There are many performance issues. Customer complain about performance, and in many cases the story is like that. Okay, I get a phone call from a customer and he tells me, listen, we had that stored procedure. It used to run for a few milliseconds. Let's say now it's 2 p.m. and till 11 a.m., like 3 hours ago, it was great. It was running for a few milliseconds each time. And since 11 a.m., something happened, and it started running for like 5 seconds each time. Okay? It was a few milliseconds until 11 a.m. Since then, it's like 5 seconds, and it kills our server, it kills our system, because this stored procedure is executed many times per second or per minute, whatever. And they say, you got to help us. Okay? So when I hear something like that, the first question I ask is, of course, what happened at 11 a.m., right? Something happened at 11 a.m. What happened? What did you do? You loaded the data, you added an index, removed an index, changed anything in your schema, updated statistics. You did something, right? And of course the customer says, no, we didn't do anything. Okay, we did nothing. Absolutely. I said that can be, and we have an argument, and that's how we start. And then we go into investigation. We try to understand what happened there, and eventually, at the end of this presentation, I'm going to show you what happened there and how we solved that problem. But let's start with what is parameterization. I want to talk about the importance of this, when is it problematic, and how we can deal with it. And when I talk about parameterization or parameters, look at this query, for example. I'm talking about this value, of course. It can go into the workloads, inequality predicates or inequality predicates. This value can be replaced, of course, with different values, and we can also use a parameter here like product ID. And this is what I'm going to talk about today. I'm going to use a case study. I call it the customers by country case study. And this is the case study. This is a very simple query. I'm going to use it throughout the presentation today. Just select from marketing.customers where country equals some country, in this case Israel, my country. I just want to see a list of all the customers in a specific country. That's all I do. We have a country column, which is nchar2, which is data type, and I'm just going to switch to the demo. I hope you can all see it. And I have the query. Okay, this is the simple query. Sorry about that. Okay, that's it. We have like 65 customers from Israel. Okay, later on I'm gonna show the execution plan, of course, but that's the case study. That's where we start. Okay, cool. Let's move on. Let's talk about plan caching. Whenever you execute a batch, okay, a batch is a few statements, okay, multiple statements bunched together, and you send them as a single batch to SQL Server. Whenever you send a batch to SQL Server, the batch goes through several stages, like parsing check and a simplification phase where the query gets more simple, and then of course optimization to prepare the execution plan, and then the execution plan is placed in cache, in the plan cache. It is placed in the plan cache in order to reuse it later, because the whole process of simplification and optimization, compilation, generating this execution plan is quite expensive, and we don't want to pay it again and again, so we want to use the same plan again next time we encounter the same query. So this is why we use the plan cache. Now, when SQL Server, the query processor, encounters a batch, it first checks whether the batch is already in cache, meaning whether there is already an execution plan in cache for that batch. If there isn't, of course, it needs to go through all the process of optimization and generating the execution plan. But if there is already a plan in cache, then it still needs to check whether the plan is valid or not. Now, why wouldn't the plan be valid? There are many reasons for that. If anything has changed since the plan was generated, like a schema change, an index was added or removed, data type was changed, anything like that, statistics were updated. Okay, for example, if there were enough changes in the column and the statistics is out of date, the statistics might get automatically or manually updated, and the plan is not valid anymore. So in this case, the plan would be thrown away, and there would be a recompile and regeneration of the execution plan. And once there is a valid execution plan, we go to the execute phase, which is executing the query, of course. I want to demonstrate. I'll use plan cache. So I'm going to create a view which retrieves data from sysdm cached plans. This is the DMV that shows us all the execution plans currently in the plan cache. And I'm going to cross-apply to two functions to retrieve the plan cache, the plan itself, the XML plan, and the text of the batch, and also to the sysdm query stats, just to get a last execution time to make it more convenient to sort. And this is how the view results look like. Now there are all kinds of things. Let me just, oh, sorry. There are all kinds of things in cache. We can see the text of each batch. We can see the plan itself. If I click that, the Management Studio, of course, presents it in a graphical way. And we can see the execution count. Now, I want to see high numbers here because this is the whole point of the plan cache. We want to see reuse of execution plans. And the object type, I'm going to talk about that. These are all store procedures, as you can see here. And the size of each planning cache and the last execution time. Okay, this is what I get from the view. I'm going to free the procedure cache, DDC free pro cache. And I'm going to run that again just to show you that it's empty now. Okay, so currently we have nothing in the plan cache, no execution plans at all. And then we have our test query. Okay, I run it once and I look at the cache again. Now I'm selecting for the same view as before. I'm just filtering by the text just to see my own execution plan, my own batch. I don't want to see other things, internal things that SQL Server runs for itself. Okay, and here it is. This is my select query. This one, it's in the cache. Here's the plan. It does an index seek with a key lookup, nested loops, inner join, and of course execution count 1 so far. And it's an ad hoc object type. Ad hoc means this is a query without parameters. It's not a store procedure. It's just an ad hoc query As simple as that. I'm going to run it again, same query, and I expect to see the execution count 2. Okay, so this is great. We have a reuse. It didn't have to go through all the phases of optimization and recreating the execution plan. This is great. Okay, we love that. I'm going to do it again, third time, and I want to see here, oh, sorry, the number 3. Oops, we get another one. What happened here? Now, the reason we didn't have another reuse, we have another one, is because of this space here. I put a space intentionally. Okay, there's no space here. There is space here, and I wanted to show you that each batch that SQL Server encounters is going through a phase of calculating a hash value. Each batch has a hash value, which is based on the text, of course, and this hash value is put in the plan cache alongside execution plan. And when SQL Server encounters a new batch, it calculates the same hash value and searches for that hash value in cache. It doesn't search for the whole text of the batch, just the hash value. So any change, small change, tab or white space, whatever, that changes the text, changes the hash value, and SQL Server treats it as a new batch. Okay, it doesn't know that it's the same batch. Of course, we don't pass queries from the application with space, without space. This is not a normal scenario. I just wanted to prove something here. But what we do, in some cases, we pass different values of parameters, and when each value is different text, we get different hash values. We get a lot of compilations. I'm going to talk about that later. Okay? Of course, if I change, again, the value here from IL to FR to France, then we get another row here. Okay, you can see here that this one has the space, this one another space, this one is FR. Each one is a different text, different hash value, different execution plan. A lot of resources are wasted, CPU resources to compile, memory in the plan cache. And imagine that this query is executed like dozens of times per second, and you get the idea. Okay? All right. You know that song? 50 Ways to Leave Your Lover by Paul Simon. I love that song. It used to work, but it doesn't work now. I don't know why, but I wanted to play that song. Anyway, what I'm saying is that just like there are 50 ways to leave your lover, there are 7 ways to execute your query, and I want to prove it. Okay, so we get the same test query. Okay, we got that view already. We're going to empty the cache. And let's start. First one is what I call non-parameterized T-SQL query. Okay, this is what we have already seen. Come on. Okay, let's look at the plan. Look at the cache. Okay, we've already seen that. It's an ad-hoc query. We change the value from Israel to France. Look at the cache again. Okay, we get different execution plans, of course. We know that. This was the first one. The second way to execute your query is a non-parameterized dynamic SQL query. Okay, this is where I build a text, a string, and I concatenate the country, the parameter here. Now, it's not a parameter. I concatenate the value. So actually, the string that I execute here has a hard-coded value of IL. Okay, so the query that I run eventually is just like this one or this one here. It's really the same. I build it, I generate it dynamically, but when I ran this statement, it's just the same as an ad-hoc query. And if we execute it and look at the cache, okay, so this is it. We see it here. It's still an ad-hoc query. And actually, the reason that it didn't reuse this one is because of the white spaces. You can see them here. If I have built the string dynamically to be exactly with the same characters as this one, it would reuse the same execution plans because it's the same thing. Okay. Of course, again, if I change only the country here to FR, but I put it here, we have a different text, a different hash value, a different execution plan, just as we expect right here. All right. This was number 2. Number 3. Now we have a parameterized dynamic SQL query. This is the first time we're going to use parameters in this presentation. Okay. So here, instead of using execute, which just executes the string as it is, we're using sys sp execute SQL. Okay, this one receives the statement, which includes parameters. Look at the statement here. I don't just concatenate the value. I use a parameter. I called it p country to differentiate it from the local variable here, which is just country. P country is a parameter defined inside the scope of the query text of the dynamic SQL here. And then I have a different variable called parameters, which contains the definition of the parameters inside the dynamic text, which is p country as and char2. And then when using sp execute SQL, I pass the statement, which is this, and the definition of the parameters, which is this, and the parameters themselves. For each parameter, I pass the value for. So for the p country parameter, I pass the value of the local variable country, which in this case is il. And when I run this one, this is a parameterized query. It's called a template, SQL template as well. And when we look at the plan cache, we see something different for the first time. Okay, look at this. First, it's a prepared statement as opposed to an ad hoc statement. A prepared statement or a prepared batch is one that includes parameters, just like we have here. And we can see the definition of the parameters in the query text. Okay, the query text now first contains the definition of all the parameters that are used inside this batch, in this case p country and char2, and then the select itself, and the query itself includes the parameter, not a hard-coded value. Okay, so this text is a template. If we change the value of p country, this text stays the same, and the execution plan stays the same. Okay, just the value is replaced, and we can reuse the same execution plan for different values. Okay, so when I do the same, I just replace il with fr here. I do the same, and when I look at the plan cache, I get a reuse. Now this is great. Okay, so if we have this query running for many times simultaneously with different values, this time we get a reuse again and again and again. We don't pay all the resources for compiling and putting the plans in cache. All right. Number 4, let's look at the client side application using .NET, for example, ADO.NET. First, let's look at the non-parameterized client side query. I have an application here. It's called customers by country. And first, let's put IL, and let's use non-parameterized query. Okay, it's good. And look at the cache. Okay, this is what I get from the application, this ad-hoc query. I'm going to show you the code. Let's look at the code. Okay, so this is the non-parameterized. Okay, I just concatenate into the query, just like I did in the T-SQL. I concatenate the text box value. Okay, and in the parameterized query, I'm going to show next. I'm using, again, p country as a parameter, and then I add a parameter object to the ADO.NET component, and I declare the type and the size and the direction, input direction, and of course the value itself. Okay, so this is how I use parameters inside the application. Sorry. And when I change this to fr, I do execute. Again, this is a non-parameterized. Okay, a lot of copy-paste here, I know. Okay, so we don't have a reuse. This one, both of these statements came from the application, one with IL, one with FR. When I use IL with a parameterized query using parameters, now essentially what happens here, ADO.NET translates that into, let me show you, into this, okay? What runs behind the scenes is the same SP execute SQL, exactly the same thing. Okay, so now it looks like that. Okay, just like we did before ourselves in T-SQL, this is what ADO.NET does behind the scenes. And that means if we replace this with a different value, we get the same behavior of course. So we get a reuse execution count 2. Okay? Let's close this one and move on. Number 6, of course, store procedure. What about store procedures? This is classic, right? Store procedures use parameters. So let's create a store procedure with the parameter country and char2 and the select statement with the parameter country. And let's execute the store procedure with a value of IL. And let's look at the cache. Okay? So here we are. We have a different object type this time. It's proc, procedure, of course, execution count 1. We get the text of the create procedure text, and the plan, of course. Oh, sorry. And when we execute the same store procedure with a different value, then of course we get a reuse. Okay, because there's no doubt it's the same text, the same object, it's the same query. It just uses different values for the same parameters. And the last one, I call it looks like parameterized T-SQL query. Okay, I see that a lot. It's a common mistake. This is what I do. I declare a local variable called country, okay, and I initialize its value to IL, and then I have the query here using this local variable. Now the common mistake comes from this. It's the same symbol for parameters and variables, and it's really misleading because parameters and variables are completely different. They have different properties and behavior, and what we get from parameters we don't get from variables. And I'm going to prove it to you. We're going to run this. Okay, what we have in cache in this case is the whole batch included in declare, everything. There are no parameters here, as you can see. It's not a prepared statement. It's an ad hoc statement. Okay, and of course, if I replace this value here, it's a different text, a different batch, a different hash value, a different plan. You know that already. Okay, so we don't get a reuse. And there is also a problem with this, with using local variables. I didn't show you before, but let's look at the store procedure, for example. Okay, if I run this store procedure and I look at the actual plan, we get an index seek. If we look at here, you can see that the estimated number of rows is 65. The actual number of rows is 65. So SQL Server knew that there are going to be 65 rows based on the value of the parameter. Okay, we have a parameter here. Its value is IL. It knows that Israel has 65 customers. Okay, when we go here using the local variable here, actually, okay, the same 65 rows, but we get a clustered index scan. Why? Because the estimated number of rows in this case is 5555.556. Okay, now that's a big mistake between 5,000 and 65. And the reason is that in this case, because we're using local variables and not parameters, SQL Server has no idea about the value of the local variable at compile time, at the time it generates the execution plan. Okay, it knows the value of the parameter. I'm going to talk about it later, but it doesn't know the value of local variables because this statement, okay, putting the value IL into the variable country, this statement happens at runtime, only later, after the execution plan has already been generated. Okay, so what SQL Server does, it uses an average estimation, which in this case is 5,000, and it's far from reality, and it's not good for us, of course. Okay, so this is a common mistake. Beware of that mistake. Don't use local variables this way. I'm going to talk about it later. Let's move on. So I want to talk about parameter sniffing. This is a very important concept in SQL Server, and it relates to what I said before. Whenever you run a batch with parameters, whether it's a parameterized query or a store procedure, on the first execution, when SQL Server has to compile the statement and generate a plan, it uses a method called parameter sniffing, which allows it to sniff essentially the parameter values in its first execution. It knows the values of the parameters. Like we've seen before with IL, it knows it's IL. It can use statistics to estimate how many rows are going to return for this specific value and generate the plan according to this estimation. Of course, like I said before, local variables are not parameters, okay, and there is no parameter sniffing or local variable sniffing, Okay, there's no such thing. At compile time, at the time of query plan generation, SQL Server has no idea about the values of the local variables. So again, beware of that. And there's a question here: is parameter sniffing good or bad? Okay, it's good because SQL Server can generate a plan based on the value, which is much more accurate than just the average estimation, like we've seen before. But it might be bad because it generates a plan based on the values of the parameters in the first execution. And then it puts that plan in cache. And it's going to reuse the same plan for later executions with different values. Now, what if a later execution with different values would require a different plan, but it's now stuck with the same plan in cache, and it's going to use the same plan for different values? It's not necessarily the best plan for each parameter value, so it might be bad. Okay, this is why we're going to look at cases where the statistics, the distribution of values in a column is not uniform. In many cases it is, and then in those cases parameter sniffing is good, okay, because the same plan would be good for most cases. But when the distribution is not uniform and there are all kinds of values, some have many rows, some have little rows, we might need different plans for different values, and then parameter sniffing might be a bad thing, and we're going to look at how we can handle it. So let's empty the cache again, and let's look at the statistics. Okay, I'm running DBC show statistics to look at the statistics, the histogram of the country column. And we can see here, of course, this is an extreme case I built for the demo. Real life cases look a bit different. We have the number of steps, 18 different countries. Most of them have like 60, 70, 60 rows, customers on average. And there is China here, and UK and US, which have very different values than the rest of the values in the table. Okay, so this is a non-uniform distribution. Again, this is an extreme case, but for the sake of the demo, this is a great case for us. We were going to use this. So I'm going to use two values here: IL, which has 65, okay, and US, which has something like 40,000 customers. I'm going to use the stop procedure we had before, and I'm going to run the stop procedure once with IL. I'm going to turn execution plan on, and using IL we get an index seek because the estimation is 65 rows, which is accurate in this case. If we use we run the stop procedure again, and we actually reuse the plan from cache now, but now with US, we still get an index seek because this is a plan already in cache. But now you can see that the estimated number of rows is 65, but the actual number of rows is 40,000. Now this is bad because we have a lot of key lookups here. Okay, the query processor thought it's gonna return 65 rows because that's what he has in cache. Okay, but in reality there was 40,000 rows, so it had to go 40,000 times and do a key lookup, which is horrible. Okay, in terms of performance. Again, this demo doesn't show you can't feel because it's a very small table, but in large production tables, it's going to be a real big mess. Okay? So, what do? Actually, this is a casino, right? It's based on luck. Really. The first time a user executes a query, a stop procedure, the value of the parameter that user is using is going to determine the plan that is going to be used again and again and again for days, maybe weeks, till some kind of trigger triggers a recompile. Okay, and if the first user executing the stop procedure is going to use a non-standard parameter value, a value that is not good for most cases, we're going to be stuck with a bad execution plan. Okay, this is a problem. Like here, for example, let's say that in most cases people use US and the first execution used IL, we are now stuck with an index seek execution plan. And in many cases, users are going to use the parameter US and are going to get a plan using index seek, which is very bad. A lot of logical reads, a lot of I/O. Okay, so what do? We have several options here. The first very simple option is to use SP recompile. SP recompile can get a parameter of a name of a store procedure or a name of a table, and essentially it's gonna assign, it's gonna mark this store procedure as invalid. Remember we talked about valid versus invalid plans in cache. This store procedure is going to be invalid as of now. Okay, nothing gonna happen at this point except for marking it as invalid. Next time a user going to execute this store procedure, SQL Server gonna find the plan, but it's gonna realize that the plan is invalid, and it's gonna throw it away and recompile the execution plan. So now the next time a user uses the US parameter value, we're gonna get a new plan which now uses clustered index scan, and the estimated number of rows is 40,000, which is accurate. This is great. But now we have the opposite problem. The next user running the store procedure with IL is going to get the same plan with scan, although the actual number of rows is now only 65. And we already know that the best plan for 65 is index seek. But we have to do now a scan each time because this is the plan in cache. All right. Oh, I can see the question pane now. Okay, let me get to this one later. I can't see it very well. Elizabeth, can you hear me?
Hi, yeah.
I can't see the questions very well, so if you can maybe copy it to the chat box or something.
Okay,
just put it to me. It doesn't show very well here. Okay, I'll go on in a while. So, this is the first resolution, not very good to do recompile. It might be a good option if there is a really rare case, a rare parameter value that happened and created a bad plan, and in like 99% of the cases we use the same parameter values or values that use the same plan. So if we just do recompile, we can get another hit of luck, and the next time if we get a better value, then we're okay. But if not, we're not. Okay, just another try. Not very good solution. The next solution is we're going to add with recompile to the store procedure here. This means that from now on, each time a user executes the store procedure, it's going to generate a new plan for the specific execution with a specific parameter value, because we have parameter sniffing, and the plan is not going to even be put in cache because there's no point, okay? Because next time another user is going to use another plan. So now I run the procedure with IL, and I get an index seek, and next time another user runs it with US, he gets a scan. Okay, so this is great. Each user, each execution gets the best plan for the specific execution with the specific parameter value, but it means we're going to pay a lot of resources in compiling and again and again and again. Like we said before, we don't want that usually. Although in some cases this could be a great resolution, because if we don't have CPU or memory bottlenecks and we can afford it, and this store procedure is not executed many times, so instead of going to more complicated solutions we're going to see later, we can just use video compile each time, and it could be a great solution in some cases. Okay, so it's good to know this one. We can take it one step forward, and instead of recompiling the whole store procedure each time, we can just recompile the statement. We can use a query hint option recompile and just compile this statement each time. So imagine this store procedure had like 20, 30, 50 statements. Okay, we don't have to go through recompilation of the whole store procedure each time. It's going to be very expensive. We can just mark this specific statement to recompile. There is a difference here, because this one means that at runtime, okay, at runtime, when we get this query, SQL Server is going to stop and say, okay, I need to recompile only this query. I'm going to recompile it now at runtime and generate a plan for this specific query, execute it, and move on to the next statement. Okay. This also means that if you are using like local variables or any calculations inside the store procedure, when you get to this point and you use option recompile, SQL Server already at runtime, it knows the values of the local variables and anything else you did so far. Okay, so this is another advantage of this method. And it's usually better than using with recompile for the all-store procedure. So again, using it with IL, I get an index seek, and using it with US, I get a scan, index scan. Okay. We can use another query hint, which is optimize for. So I can tell SQL Server, ignore the value of the parameter you get in the first execution, okay, when you need to generate the plan. Assume you got US, okay. Always generate plan assuming you have the parameter value of US, even if the first execution tells you otherwise. Of course, the result set is going to be based on the actual parameter value. But for the sake of the query plan generation, we're going to use this parameter value each time, okay? So if I'm going to run the alter procedure statement, although the first time I'm going to use IL, it's going to generate a plan based on US. Let's see that, okay? So here, I used IL, but I got a scan. And you can also see that the estimated number of rows is 40,000 based on the value US, while the actual number of rows is 65, which is the number of Israeli customers, okay? I can also click properties on the select operator, and I want to show you the parameter list here. You got the parameter compile value and the runtime value. So you can see what was the value used in plan generation and what is the actual runtime value in this specific execution. Oh. Sorry. So, of course, now if you go to US, now we're going to use the same plan already in cache. We have a reuse, scan, so this is obvious. Next, solution number 5. This is the most complicated solution, but the best one in terms of the balance of performance between number of compilations and effectiveness of the plans generated. So here, I'm going to create a table. I'll call it common countries. It has the same structure as the statistics, the histogram, okay? And the reason is I'm going to insert the values of the histogram into this table. Okay, this is where I do it. I run DBC show statistics with histogram to just return the histogram itself as a result set, and I put it inside an execute just so I can insert the result of this execute into my table. And now my table contains the histogram itself, just like the statistics of SQL Server, and I can use it and manipulate it in order to distinguish between common values like China, UK, and US, and uncommon values like all the rest in this case. Okay, so now this is where the business logic, your specific logic and understanding and knowledge of the distribution of values comes into play. In this case, all I do is count the number of rows and say, okay, values, countries that have less than 1% of the number of rows in the table, I'm going to delete them and treat them as uncommon values, and I'm going to leave only the values at the countries that have more than 1% of the rows in the table. And this is going to leave me with the 3 values you already know. Okay. Now again, this is a very simple case for the sake of the demo. In reality, it's going to be much more complicated to distinguish between the common and uncommon values, and you have to play with it and do some fine-tuning over there. But eventually, you're going to get around the right calculation to do that. And now, what I'm going to do, I'm going to create a new store procedure, customers by country _ common, with the same parameter definition and the same query, just like before. And I'm going to create another one, exactly the same text with the name uncommon. 2 store procedures, one common, one uncommon, with the same query, same parameters. And now I'm going to alter the external store procedure, the one that the application calls, okay? And all it's going to do from now is going to check whether the parameter value exists in my common countries table, whether it's a common value or not. And if it is a common value, it's going to call the store procedure with _ common. If it's not, if it's an uncommon value, it's going to call the uncommon store procedure. Now the idea here is that this store procedure is actually becoming a dispatcher. It's going to decide for each common value based on my logic, it's going to call this store procedure. Now the first time this store procedure is called, we're going to have parameter sniffing, and the plan is going to be based on that common value, and it's going to create a clustered index scan plan. And the first time this one is called with, of course, an uncommon value, we're going to get an index seek plan. And again, this store procedure, the external one, is going to push common values into this one with the clustered index scan, and it's going to push uncommon values into this one. And the idea here that we're going to pay the execution plan generation only twice. One to generate the common plan and another one to generate the uncommon plan, and that's it. From that point on, we're going to reuse each plan for its own parameter values, and this is the best solution in terms of balance. Okay, let's just demonstrate it. We go with IL once, we get, okay, this is the checking for existence of my common countries table, and this is the index seek I'm looking for. And we use US, and we get the clustering and scan, and that's it. Okay, we've done with compilations. Now we can reuse the same plan again and again for the common values and for the uncommon values, and this is a great solution. It's more complicated. It requires maintenance, of course. We have to have some kind of a job that at once in a while truncates the table and generates the statistics again, because statistics change, and we need to see if the values change. So we need some maintenance here, and the logic of what is a common value, what is the uncommon value, is quite tricky. We have to play with it for a while, but once you get the hang of it, it's really a great solution. Okay, so these are a few methods to handle non-uniform distribution. And let me move on. Elizabeth, do we have questions? Let me see. Oh.
Just the one that I've put in the chat pane.
How does the plan cache? Yeah, I see it now. What if the store procedure has dynamic SQL inside of it? Okay, so if we have a store procedure and we have we generate dynamic statement inside the store procedure, essentially the store procedure has no meaning, because when we execute the dynamic SQL text, it is executed in a different scope. Okay, it is a batch by itself, and it goes through all the phases of compilation. It puts in the plan cache only the batch that inside the text. So there are actually two batches here: the batch of the external store procedure and the batch of the dynamic text inside the store procedure. And what matters here is, of course, the batch inside the dynamic text, because this is the query that we are running eventually. Okay, so the store procedure has no meaning in this context. Can we use option optimize for unknown? Yes, sorry, I didn't talk about that. When I talked about optimize for, one of the query hints, we can also use optimize for unknown. Okay, in cases we want to disable parameter sniffing, and we want to tell SQL Server ignore parameters altogether and just optimize for the average case, like we saw with local variables. So this is also a possibility in cases where we don't want parameter sniffing at all. We have parameters, we want to disable parameter sniffing. We can use a query hint, optimize for unknown. Thank you for that comment. Okay, I don't have much more time. I want to have some more things to talk about. Okay, so this is a summary of the possible solutions we had for dealing with non-uniform data distribution. Again, SQL recompile to just try again for the next time. Maybe we have better luck with the next parameter value used. With recompile at the store procedure level, we'll trigger an execution plan generation for each and every execution of the store procedure. We can use option recompile at the statement level to just recompile at runtime a specific statement, which is usually better than recompiling the whole store procedure. We can use, again, option optimize for with a specific parameter value or with unknown to tell a SQL Server how to optimize a query based on which parameter value, regardless of the actual values used in the first execution. And of course, we have the more complex solution using multiple store procedures and the histogram that we have to calculate which are common values, which are uncommon values. Okay, now I want to talk about a specific area which is also very common. I see it a lot with our customers, which is changing parameter values. Okay, so the optimizer uses parameter sniffing, and it sniffs the values of the parameters at compile time as they are passed to the store procedure. Now, if you change the values inside the store procedure, at runtime, the values are different, but the plan was generated based on the values at the entrance to the store procedure, and there you're going to have a problem. Okay, I want to show you a demo of that. So let's look at this scenario. We have a procedure here called customers by last purchase date, and it has a parameter date with a default value of null. And inside the store procedure, I use just video compile here just for demo sake, okay, to show you different scenarios. Now inside the store procedure, we check the value of date, and if it's null, we set it to last week. Okay, so the case here is like that. We have a report in our application which retrieves the customers that has purchases since a specific date. There is a date picker, a control in the report that users can pick the date. And users told us that in most cases they want to look at the last week. And they said, okay, instead of having us to choose last week each time, just let us hit submit, and the default would be last week. Okay, so the implementation was pass null to the store procedure, and the store procedure said, okay, if it's null, we're going to use last week right here. But the problem is that parameter sniffing sees the value null. But at runtime, we get a different value, and when we use the value of the parameter here, okay, it's not the same as the plan was based on. So if we, okay, let's create an index, of course, on the date. And if we use the store procedure with some value, specific value, okay, we're going to be fine. Oh, sorry. We're going to be fine. We're going to get, in this case, a scan. Okay, in this case, it's the old table. It's 100,000 rows. We see that the estimate number of rows and the actual number of rows are identical because the same value which was sniffed here was used here. No problem there. But if we use the same store procedure, and again, we recompile, so it's going to be recompiled again with the default value, which is null, we get an index seek. The estimated number of rows is 1. It is 1 because SQL Server thinks it's null, and there are 0 rows with the null values compared to each comparison to null equals to false. So there are 0 rows returned. It always reports 1 instead of 0, but it actually means 0. But the actual number of rows is 2,000 and something, and for that, the better plan would be a clustered index scan. I'm going to show you that in a minute. Okay, so we get a bad plan in this case. Okay, and the way to handle this is similar to what we did before. We're going to create another inner store procedure with the same parameter and the same query. And now the external store procedure, the one that the application calls, is going to do, again, the if. Okay, if it's null, you're going to change it to last week. And then instead of running the query with the parameter that has been changed, I'm going to call the inner store procedure with the parameter value after the change. So now, whether it's a specific value or whether it was null and replaced with last week, whatever it is, we now have the final value here, and we can call another store procedure with a final value, and that other store procedure is going to go through parameter sniffing as well, and we're going to use the actual updated value, and this is how we overcome the problem. Okay, so now we use the store procedure, the external store procedure, the same thing. Okay, it's completely transparent to the application with the default value, but now we get a scan, as you can see, because it knows that the estimated number of rows is 2,266. Okay, so this essentially solves the problem. So don't change the values of parameters inside store procedures if you don't have to, and if you have to, do whatever you need, do whatever calculations you need to do, and when you're ready, when you have the updated values, go and execute another store procedure to use the parameter sniffing there with the correct values. Okay, we have another question here. A common technique to avoid parameter sniffing is to copy the procedure parameters to local parameters. Okay, this is true. If we want to avoid the problems of parameter sniffing or the influence of parameter sniffing, we can use local variables. We can declare local variables inside the store procedure and copy the values of the parameters into local variables, and then use the local variables in our queries. So essentially, there is going to be parameter sniffing, but it's not going to have any effect because none of our queries inside the store procedure are going to use those parameters. They're going to use local variables. And as we said before, at the compile time, local variables values are unknown. So it would be just like we said before, just like using optimize for unknown. Okay, it's the same behavior. We can use local variables. We can use optimize for unknown. In both cases, we get a plan generated on the average statistics without knowing the actual values, which again, it could be good, it could be bad. Okay, but it's a technique you can use for those cases where you want to disable parameter sniffing. Okay, absolutely. Okay, the last topic I'm going to talk about is simple versus forced parameterization. Okay, let's talk about simple first. Parameterization is a property at the database level. Each database has a parameterization property, and the default is simple. Okay, you have a simple parameterization. Sorry, simple parameterization means that SQL Server is going to parameterize queries by itself without asking your permission, but it's going to do that only in those cases where it knows for sure that whatever the parameter values are going to be, the plan is not going to change. Okay, there is no risk at all. It means that in some cases you might see queries that you write, okay, that don't use parameters, they use hard-coded values, and SQL Server is going to translate them without asking your permission to prepared statements with parameters and execute them because it knows that it's going to be better anyway. Okay, there is no reason in those specific cases to use hard-coded values and recompile the plan again and again. Okay, I'm going to show you that in a moment. This is simple parameterization. If there is even the slightest doubt that some parameter value might produce a different plan, SQL Server is not going to parameterize the query under simple parameterization. Forced parameterization, on the other hand, means that essentially all queries are going to be parameterized, but there are some limitations, so most queries are going to be parameterized, and this could be, again, good in some cases, it could be horrible in other cases. I'm going to talk about that in a minute. Also, I said that parameterization is a property of the database, but actually you can apply forced parameterization or simple parameterization in database level, but also at the query template level. I'm going to show it in a second. I can use simple parameterization for the database and force parameterization for specific queries, or vice versa. We can use force for the database and use simple parameterization for specific queries. Okay, let's look at that. Empty the cache again. Look at our test query once again. Look at the plan. Okay, so our test query, again, there are no parameters here. We've seen it before. There are no parameters in this query. If you look at the cache, we can see that this is an ad hoc query, no parameters here. But now, okay, we search by country. Let's look at this one. This time, we select from customers and we search based on the ID. Now, the ID is a primary key. Okay, so we search for specific row 1, 2, 3, 4. Again, there are no parameters here, right? It is an hard-coded value. But if we look in the cache, then we can see that this is a prepared statement. SQL Server decided by itself that this is going to be a parameterized query. It generated, it invented a parameter here. It called it 1, okay, of type small int, and it used this one, okay, instead of my 1, 2, 3, 4 hard-coded value, okay. And now, if another user is going to use the same query with a different value, thanks to SQL Server, we're going to have a reuse, okay, because it's the same template, the same prepared statement. Now, the reason SQL Server allows itself to do that is because we have a primary key here. So no matter what the value here is going to be, okay, this query is going to return a single row from the table, and it's going to use the same plan every time, which is a clustered index seek. Okay, it doesn't matter by definition what the values are going to be, and there is no risk in parameterizing this specific query. Now, this happens under the simple parameterization. If we look at sys databases, we have a column called is parameterization forced, and we can see that it is 0, means it is in a simple parameterization. We're going to change it to forced, and we're going to run the query with the country again. And now you can see that we have a prepared statement even for the country, and it uses end voucher 4000 parameter, okay, which is the default for text. Even if we use here just 2 characters, it needs to generate a parameter that is good for all cases. Okay, we're going to go back to simple, and I want to show you how to parameterize a specific query and not the old database. Okay, so we have a stop procedure called sp get query template. We pass the template of the query with some value, doesn't matter what the value is going to be here, and it outputs the statement with it replaces the value with a parameter and the definition of the parameters. Okay, and I'm going to use the statement and the definition of parameters with the next stop procedure, sp create plan guide. A plan guide is an object in SQL Server that guides query hints for a specific query. So when it encounters this statement as a template, okay, with these parameters definitions, it essentially adds this query hint option parameterization force to this specific statement. Okay, so when I run this one, I'm still under the simple parameterization at the database level, but for this specific query, let me show the plan. Okay. So you can see here in the seek predicates down below that we use a parameter here, and not in how to code value. And if we get, we do it with fr and with us. Okay, we get the same index seek even if it's US, because we reuse the same plan. We get another 3 execution counts. Okay, even when we're under the simple parameterization, because we use force for this specific query template. Okay, I just dropped the plan guide, and that's it about simple and force parameterization. I know that there's a lot of scripting here. I'm gonna upload the PowerPoint slides and the scripts, all the scripts I use, so you can download them and look at the comments and play with it. So don't worry about that. Now let me just summarize. Okay, so parameterization is a very important aspect. Okay, as I said before, I see it a lot. I see many performance issues that originate from the wrong behavior, the wrong use of parameters. And again, it leads to poor performance. I said it before. Let's talk about the tips from this position. The things I want you to go out with are when data distribution is uniform, more or less. Okay, we want to use parameterized queries. We want to use parameter sniffing. We want to reuse the same execution plans again and again because they are good for most cases, because data is uniform. When data is not uniform, parameter sniffing might be problematic, and then we're going to have to trick it somehow, either by using recompile, by using your own method to distinguish between common values and uncommon values, maybe optimize for unknown things we talked about today. You're going to have to use one of those methods to mitigate the problem of your non-uniform distribution. Again, avoid the use of local variables. They are not parameters. There is no parameter sniffing associated with local variables, and SQL Server knows nothing about their values at compile time. Don't change parameter values inside a stop procedure, because there is a difference between the plan that is based on the values of the parameters at compile time and the actual values after you change them at runtime. Okay, so the plan is not going to be right for the actual execution. And force parameterization of queries only when you have no other choice. Okay, this is a problematic thing, because if you have ad hoc queries that go through a lot of compiles, you can use force parameterization. But then again, if you have non-uniform distribution, using parameterized queries and reusing plans might be problematic more than it might help. Okay, so it might be a problem. You have to really test it carefully and see if it can help you. In some cases, when a system uses a lot of non-parameterized, a lot of ad hoc queries, sorry, instead of rewriting all the code, although this is the right solution to do, you can just try and test it on another environment and see what happens when you use forced parameterization, and it's always better to do it on a specific query template level like I showed before. Back to the story, I said before, 11 a.m., something happened, and since 11 a.m., the stop procedure started to run for like 5 seconds instead of milliseconds before. And what happened there is that at 11 a.m., there was a statistics update, and how to update statistics triggered by the database because there were enough changes in the table, which caused a recompile of the stop procedure. And we had bad luck because the next time the stop procedure was executed, it was executed by a user with a parameter value which is not common and generated a different plan from the plan used till 11 a.m. And then we are stuck with this new plan, which is bad for most cases, and this plan executes for 5 seconds. Okay, so the customer was right. They didn't do anything. They didn't change anything, and it happens. It just happens. This is the way SQL Server works. You have to be aware of that, and you have to know what happens and what to do when it happens and how to identify those problems. Okay, so I see that a lot. I just want to point here 2 resources, very good, quite old but still very good. One by Greg Lowe and one by Kelly Delaney about plan caching and about parameter sniffing. Again, you're going to have the presentation, so you're going to have the links as well. And I just about the end of the presentation time, but I have some time for questions, right? Let's see. Does having a clustered index that is not unique have a negative effect on performance as the index? Let me see. Is there a? I'm not sure I understand the question about the clustered index which is not unique. Could you just use an is null in the parameter in the beginning? Okay, when I use the stop procedure that checks for the null, okay, if the value is null, then use the last week. Instead of that, I could use the is null function inside the query. Okay, this is another method to try and resolve this problem, but it's not going to help. It's not going to help because again, at compile time, SQL Server doesn't know the value, the result of the is null function, and it's going to treat it as an unknown value. Okay, just like a local variable, it's going to produce a different result. It's a different problem. Okay, it's not like assuming it's going to be null while it's actually something else, but this time it's going to be a different problem. It's going to be an unknown value. Okay, but it's still a problem. Okay, you're not going to use the appropriate value eventually. Let me see if there are any other questions. How are you handling when you're updating statistics? What do you mean? How am I handling when I'm updating statistics? Again, I'm not sure I understand the question. Sorry. Can a procedure be inefficient even though actual number of rows and estimated number of rows are equal? Well, that's a good question. In my opinion, from my experience, most, actually I think all, when you have a performance problem and you look at the specific execution plan and you want to see what the problem is, I always look for operators which have big differences between the estimated number of rows and the actual number of rows. I don't look at the cost, okay? The cost we chose in percentage. The reason I don't look at the cost is because it is an estimated cost. It is always an estimated cost. And if there was a wrong estimation, then the cost is lying. You don't want to look at the cost. You want to look at the differences between estimated and actual. And when I see an operator like an index seek or anything like that that adds a big difference between the estimated and actual number of rows, this is where the problem is most of the times, almost always. Okay, this is the reason for the bad performance. Now all I have to do is to try and understand why there is a difference. It might be because of out-of-date statistics. It might be because you're using implicit conversion. It might be because of many reasons. But yes, I look at those places where there is a difference. And to your question, when there is no difference, well, it doesn't mean there are no problems in the query. Okay, you might be using a wrong syntax. Maybe you write the query in a bad way. You can always try to rewrite the query. For example, instead of using roll number, use cross apply or vice versa. You have many techniques to write the same query for the same results. And although you get the same the values of estimated and actual number of rows, you still might have bad performance, and you still might be able to improve performance. But in most cases, from my experience, if you have bad performance, it's going to show up as the difference between estimated and the actual number of rows. Okay, what else? Okay, let me see if there's something else. I've seen a lot of data warehouse use clustered indexes that are not unique. Can this cause performance issues because based? Oh, okay. So yes, in most cases, clustered indexes are made unique, but they don't have to be. And yes, of course, there are many cases. For example, if you use a clustered index on a date column, okay, you can't say the date is unique. You might have this, 2 rows with the exact same date time. Okay, so the clustered index is not going to be unique. It's going to make sense to make this column a clustered index, but it's not going to be unique. And well, if it's a problem, I don't think you can say it's a problem. Okay, because first it's a business need. Okay, you can't make this column unique because it's not unique. In some cases, there's no influence on performance. In some cases, if a clustered index would have been unique, it would have improved performance. But again, in most cases, it's a design issue. Okay, it's a requirement. It's a business requirement. If it should be unique, okay, business-wise, then make it unique. If it can't be unique, it can't be unique. Okay, so I don't think there's a question there. We have other questions? I think not. Okay, well, with that, thank you very much. I have a slide for that. Yep. Again, I enjoyed this topic. I hope you learned something new. I hope you can use it with your systems and make them better. And again, I'm going to upload the presentation and scripts, and you got my email there also. So if you want to ask anything later, you can do that, no problem at all. Thank you very much, and goodbye.